Today we're going to be studying the concepts of a pass and a touch and what they mean and what we can use them for. The reason why it is important to study what a pass and a touch is because we need the two terms, these terminologies, in order to sketch rational functions and other high degree polynomials. For example, if I have a function, a rational function, being defined with x to the third plus x to the second plus x divided by 3x, how am I supposed to have a rough sketch and draw one so that it closely resembles the actual graph? Well, we cannot do it unless we understand the concepts of what a pass and a touch is. So that's what we're going to be explaining in this video. With y is equal to x, it passes through the origin 0, 0. When it passes through 0, 0 from the left hand side, it'll go straight through it, maintaining the same direction. It'll go constantly in this y is equal to x direction. And if we go vice versa, if we come down from the right hand side, it will come down past the origin, which let's say this is the origin, and continue maintaining that same direction and speed. That's the terminology for what a pass is. The line is essentially just going straight through it while maintaining a direction that is the same with its previous direction. So at this point, for example, if I have this point and I call this point A and I call this point right here point B, the direction that I came from negative infinity, from right here, I came from negative infinity going in this direction. But then when I pass through point B, it's still going in that exact same direction from negative infinity, or from any point previous than point B. That's what we call a pass point. Moving on to a touch. First thing that we can notice is, unlike y is equal to x, y is equal to x is in the first power. Y is equal to x squared, x is raised to the second power. This will change the point that it passes, in this case the origin right here, to be a touch. If I come down from the right hand side of this parabola, and I come down and I approach the origin, and I come through the origin, but then you see I'm changing the direction, I'm going up again. Unlike for y is equal to x, no matter how we approach the origin, we will always be maintaining the same direction and speed to another point. But unlike a parabola, it'll come down from the right hand side, going down and maintaining a downward direction, but then passing, instead of passing it should be touch, but after touching the 0 point, it will immediately bounce up. And that's the terminology for what a touch is. It will touch a specific point. For example, this f of x function touches it and then immediately goes the other way. That is a good visual and understanding for what a touch is. A touch can also be applied for y is equal to x raised to the third power. We see here that coming from negative infinity right here, we go up, and we go to the origin. But the minute we pass the origin, that very second, we change a direction, and this direction changes to suddenly going up again. And you might be thinking, well, when I'm coming up from negative infinity, I'm also going up, and after I pass the origin, I'm still going up. So why is it not a pass but a touch? And the reason for that is because when we come up from negative infinity and we pass the origin, we are going in another direction that's independent from the direction that we're coming up from the bottom, even though the direction that we came from the bottom is an upward direction. So what I mean by that is, if I draw another rough sketch of one, and I come up, and let's say this is the origin, and I'm coming up in this upward direction from negative infinity. If I were to make this a touch point, then f of x, instead of f of x being equal to x to the third power, it would have to maintain that same direction, that second before it touches the origin, that same direction. So let's say the second before I touch the origin, it's in this red arrow direction. Then the minute after I touch the origin, I must continue to go in that red arrow's direction. So I have to continue in that red arrow's direction, hence maintaining our definition for a pass point. Hence creating this f of x to be passing the origin instead of touching it. Another terminology for touch is cross, C-R-O-S-S, to cross a certain point. And we will be analyzing how we can apply these two terminologies in our next video when we begin to understand the process of sketching rational functions.